This is the Scion. The Scion is a biofeedback interface for Eurorack. It allows users to interface their modular with plants and other living things as control sources. It features a conductive electrode on the faceplate to allow direct interaction by the user, in addition to the main sensor input that connects directly to plants via TENS cables. It connects to living things via its main sensor input, using TENS cables that can be attached directly to plants. This electrode is normalized to the main sensor input. By using a jumper on the back of the module, it can be connected in parallel for simultaneous control. The biofeedback from the plant is translated into 4 separate channels, which are arranged vertically on the module. Each channel generates a control voltage signal ranging from 0 to 5 volts, as well as a gate signal with a random duration. There is an attenuator and analog slew limiter per channel that affect the control voltage outputs. To demonstrate, I'll set up a simple linear FM patch using channels 1 and 2 of the Scion to control the pitches of the carrier and modulator respectively. The gate of channel 1 will trigger an envelope opening an output VCA. The global controls of the Scion are the sensitivity pot and the note density fader. Each of these parameters are CV controllable. The sensitivity pot determines the responsiveness to the main sensor input. This allows for the user to quickly adapt to the differences between plants and lets them specify the responsiveness of the module. All the way up, the module will continually respond to the plant. Reducing the sensitivity, it is possible to find a threshold at which point the module will only trigger when the user interacts with the plant. With the density fader all the way down, only octave intervals will be generated from the CV outputs. Increasing the fader level will add note intervals following the circle of fourths until the range is fully chromatic. Each channel also features a gate input jack and a hold button. The hold controls will freeze the current state of each channel. When each new note is generated, it has a random gate duration ranging from 100 milliseconds to 3.5 seconds. The gate input on each channel will enable ratcheting, whereby the gate duration is divided into either 4, 8 or 16 subdivisions. This allows for direct control over rhythmic bursts within individual notes. In addition, the Scion has 2 alternate modes. These are accessed by momentarily pressing all 4 buttons at once. Buttons 1, 2 and 3 select which mode is enabled. Pressing a blinking button will select that mode. The default mode is selected by button 1. In this mode, as demonstrated so far, output voltages are quantized to the chromatic scale. Mode 2 behaves much like mode 1, but has an additional random voltage offset that is applied to the CV outputs. With the density fader up full, the outputs will generate completely random voltages ranging from 0 to 5 volts. The third mode generates voltage intervals quantized to the harmonic series. Moving the density fader will add in additional harmonics up to the 12th overtone. We are currently hearing 4 oscillators tuned to a unison being pitch controlled by the 4 channels of the Scion. In this mode, the density CV input now behaves as a voltage follower that defines the fundamental of the overtone series. This means that the Scion can generate harmonics related to an external sequence or control voltage. In addition to the three modes, there is a secondary gate input function. This is enabled by selecting the fourth button during mode selection. The gate inputs will now force a note change while the channel has an active note. The last remaining output jack is the raw signal generated by the analog circuit used to interpret the biofeedback from the input sensor. This signal is a simple square wave that responds directly to the sensor. Changes in pressure on the electrode will result in fluctuations in pitch. This signal is the core of the Scion's functionality. It seemed a waste not to have it accessible for the user in its raw form.